So quick demo of the frames I have. So you can recognize this. This is the 5-inch gecko frame that I printed in carbon fiber nylon. It's got flex to it now that it got wet. I tried annealing it, everything, but it's just the material not good enough, so I never ended up flying this yet. So then I decided to come up with something else. This is very similar, as you can tell on the shape. This is forged carbon fiber. I guess one of my first initial designs that I did. Never got to build it. I guess I didn't like the shape. The mountings were kind of meh. Then I iterated. It's something different. Much lighter weight. It was alright, but still didn't fly it. Found not to be too great. Then another iteration came. This was these actually was flying. These are slanted motors or offset motors, you can tell. Tried to go with circular stuff, more organic curvy shapes. I actually flew. One of them flew very nice. Then after that, I decided to not to do the offset motors because it was kind of a pain to make them. The molds were kind of weird, more complicated, so I made just a circular frame. Made a lot of reinforcements, and it's actually pretty strong. All of the impacts are distributed across the frames. If it crashes, falls on any of the arms. Made the arm bumpers, which are TPU, and they have the I guess kind of springy thing when they're compressed. They absorb a lot of the impact, a lot of the force and energy is absorbed. So even before it gets to the frame, it's already absorbed at the TPU cards. Then I guess another variation came, slightly lighter. These frames are about 650, actually no, 60 to 70 grams, like 65 grams, the circular ones. Then I figured, I ran some simulations and I figured that the resonance or the frequency analysis showed that the circular frames were not had some frame vibrations. So then I created this design, which is kind of became the most prominent design choice, and the simulation showed that this structure was a lot more stiffer than the circular ones that I did before, and I kind of made it with a bunch of things. XT60 connection, solid, and obviously these points are for the canopy to mount on. These are very kind of tall and thin arms. So then I did another variation. This actually came before the previous one. This design, like a triangular design, was okay, but this was more superior in resonance response. The weight is probably like 5 grams of difference, but this was pretty nice, but the resonance wasn't as good because the arms were thinner and they were more like square cross section, more closer to a square than rectangle. These are they have like a really tall and narrow side, not like the ideal I-beam structure, but close enough. Then I guess my last iteration last two frames that I did. This one was, I didn't do any additional XT60 connection points or anything else. I just did it very symmetrical. It's all symmetrical on both axes, X and Y, and I guess Z, except the stack location, it's a little bit offset. And I actually made press nuts in here. You can see these bulges that over here, they're actually press nuts installed there while the carbon fiber was curing. This proved to be very stiff. I can't bend it with, like, when I tried my hardest, I can't bend it. I'm not pushing it like to the max limit to break it, which I'm gonna be doing first. I'm gonna be doing bunch of tests with the weight of the approximate final weight. I'm gonna attach some weights, and I'm gonna do drop tests, smashing it into the ground, into concrete, and see the durability. And I guess here comes the final design that's very much identical to this, but I decided to make it my life a little bit easier and or harder at the same time. Have XT60 points where I can mount points for the canopy, just to drill holes, put some short standoffs, put the canopy from say I have the open racer canopy for, this is DJI O4 I think, or O3, I remember exactly, so it just goes like that. Then I made some ridges here for the battery, to have a battery strap in here installed. I have to drill some holes there for the battery strap to go in, but essentially we'll have a, maybe other way around, but the canopy mounts, protects electronics, and houses the VTX and antenna, and everything else is solid, solid carbon. No connections, no hardware besides mounting the stack and the canopy to the frame. I also have my own canopies, which I came up with. These are, I don't know, this reminds me of some kind of animal. It actually had a XT60 there, but it's not gonna go on this one, this frame. That was my previous iterations. So the VTX mounts inside there, and then the camera, I tried to make this as much forward as possible so I don't have props in view with the DJI O3, O4 cameras. The open racer one is fine, but you have to run like a 45-degree angle on the camera to have no props in view. Otherwise the props are right taking half of your screen. Then I guess my latest iteration is on the canopy. This is DJI O4. I'm gonna be installing it, I guess, on this frame to test it out finally. It's got a separate camera pod that attaches to the actual canopy with the VTX and antennas, and it's got places for the standoffs. Same setup as the open racer. The spacing, I made them the same so they're interchangeable, so I can easily swap one canopy for another, or if someone else wants to print like an open racer canopy, they can just use it in the frame, and me included. So it's gonna go up like this, some sort of this way. This is adjustable. I got this idea from one of the frames that made an adapter, and I basically modified a little bit, and now you can undo the screw a little bit, you can adjust the angle and have a lot of protection for the camera. So yeah, I'm gonna be doing probably do a video once it gets warmer outside, actual durability test with with one of the frames. This one didn't come out as great as I wanted. The carbon, the mold kind of got broken in places, so this is my spare, or the actual sacrificial frame that I'm going to be doing durability test on. And it's pretty strong by itself, but the dimensions are kind of off because of the mold process got not the way as expected to go to. So I'll be doing durability test. Maybe I'll maybe make a YouTube video out of this to show what it's like. And these frames, I forgot to mention, this is like 78 grams. Right now it's 78, but once I drill all the holes for the motors, for all the stacks and everything, it's gonna go a couple of grams lighter, so it's gonna be about 75 grams. Plus the canopy is about 30-ish grams, so we're talking about 120 grams with canopy and all, I guess, all the TPUs. But it's much stronger. This design is so much stronger than the split deck, triple deck popular frames that are out, which means it's going to be much better in resonance. I'm going to test the durability, which I think is going to be great, given that I'm going to be having these type that I designed, these types of arm protectors. They're going to absorb a lot of the shock, a lot of the energy into them. Or if it hits the ground, concrete, obviously if it hits in the middle, somewhere in the pole, that's a different story, but yeah. So I got a lot of frames done. I only flew a couple of them. I was really impressed. And I just made it a little bit better, which I'm going to be trying out once it gets warm outside to go out and fly normally. Right now it's super cold, snowy. Right, I guess later.